Hi calculus students, so we're going to be starting lesson 2 today. Lesson 2 is on determining limits using algebraic properties of limits and algebraic manipulation. So in our last videos we practiced, first we just found out what is a limit, what does it mean to find a limit, and then we practiced finding limits from graphs and tables. So now we're going to start looking at more equations and how to find a limit from an equation. We're going to start like last time with a warm-up. So go ahead and pause me and take about 5 minutes or so to try this on your own. So hit pause. And now that you've tried, let's see what the real answers are, or the correct answers are. So number 1, at which values of x does the limit not exist? So we learned before that a limit does not exist if the left and the right hand limits are not the same, so if they go to different points. So let's look for where they go to different points. Some of you may have been tempted to say that here at -4 the limit does not exist because of this hole, but because from the left hand side and the right hand side the limit is actually 2. It doesn't matter that there's a hole there, the limit is 2. Same thing over here. The limit does exist at x equals 6. The limit is equal to 5. The function value is equal to 2, but not the limit. So, the only place where the limits from the left and the right are not equal is right here at 1. So the limit from the left as x approaches 1 is 4, and the limit as x approaches 1 from the right is -2. So at x equals 1, the limit does not exist. And if we were to write this out in full function limit notation, we would say the limit as x approaches 1 of f of x does not exist. Okay. And then problem 2, at which values of x is the limit of the function equal to 2? I'm gonna erase this stuff here, it's kind of busy. So where is the limit equal to 2? In function notation or limit notation it could look like this. I'll put a little question mark there. At what values of x does the limit equal 2? So I'm gonna kind of highlight where x is equal to 2. Right there. And so you might be tempted to say it's any place where the function like goes through 2. Here I can say at x equals 6 that f of 6 equals 2, but as we already talked about, the limit as x approaches 6 of f of x equals 5. So not there, but right here at -4. So the limit as x approaches -4 of f of x equals 2, and you could just say x equals -4. That's fine. For both of these, we could just say that. Give the x value. Cool. So that was kind of practicing what we learned previously. Now let's get into our properties of limits. You can kind of think of these just like we have properties of exponents and properties of logs. Here are our properties of limits. And they're kind of similar to like exponents. So you should write this down. Here is an official definition. So let b and c be real numbers. So b and c are just numbers. And n be a positive integer. Remember, this word integer is really just means whole number. Okay, it's just a whole number, pretty much. And let f and g be functions with the limits. So it tells us that the limit as x approaches c of f of x equals L, and the limit as x approaches c of g of x equals k. So just giving us different limits at c for these functions. And so some limit properties, scalar multiple, that just means if you're multiplying by a constant. You can also think of this word scalar as constant multiple. Scalar is just kind of a college level word. So if you're more comfortable with constant, go ahead and just change this word scalar to constant if you want. So you can multiply your limit right here times a scalar or a constant, and then it'll multiply there as well. That's it. Sum or difference means you can add the two limits together and it will equal the limit values added or subtracted together. You can take the product of two limits, quotient of two limits, as long as k does not equal 0, because you can't divide by 0, obviously, and then you can raise the limit to a power. Okay, pretty basic rules. And in the next example, I'm going to show you how we can apply these, or what this might look like on your AP exam. So here's example 1. So just like in the definition on the previous page, we're given two different functions, f and g, and we're given the value of the limit of f of g as x approaches c. So it looks very similar to the notation that we were given on this previous page, except we're given actual limit values. So we're asked to find the limit as x approaches c of 4 times f of x. And if you go back to your limit rules, this is the same as the scalar multiple rule or the constant multiple rule. So we can just say this is the same as the scalar or the constant times whatever the limit was. In this case, the limit is 3/2. I'll just do some simplification before I multiply, so that's equal to 6. That's it. And then my quotient, again, I just have to check to make sure that the limit as x approaches c of g of x is not equal to 0. It's not, it's equal to 1/2. So I can just take my limit values and divide them. I'm going to rewrite the division as multiplication. So instead of dividing by the fraction, I'm multiplying by its reciprocal. Those cancel out, and it's just equal to 3. So that's just how you apply the rules. This is something more similar to what you might see on the AP exam. They give a lot of tables. You have to get comfortable reading tables. So it says the table above gives selected values and limits of the functions f, g, and h. So you have different limits, as well as the function values. So I want to remind you, vocabulary, these are function values at the point. So function values are always what's happening exactly at the point, and then these are the limits as the function approaches the point. So I just want to continue to clarify the difference. The function value is what's happening exactly at the point. The limit is what's happening as you get close to the point. Anyway, so we can apply these same rules. You can see in part A we have a lot of different rules happening at once. I see, so like going back to my definitions, I see the product, I see these first 3 rules. So the constant, multiple, sum and difference, and the product rule are all happening here. So I have the product rule where h is being multiplied times those functions. I see I have 5 is my constant multiple, and then we're adding 5 f of x plus g of x. So it's 3 rules all in one. But that's okay. So we just apply it like this. So we're looking at the limits. So I want to make sure, because of this limit right there, I'm using all of my limit values here, because they're all inside the parentheses with the limit. So I'm not using any of the function values right now. So the limit as x approaches 2 of h of x is 2. Then I have my constant times the limit as x approaches 2 of f of x, which is 4, plus the limit as x approaches 2 of g of x, which is -6. Let's follow order of operations. Cool. 28. Okay. This one's just a little bit different because I have this function value outside of the limit. So I just need to make sure to use the function value instead of the limit. So h of 2 is equal to -3. You get from right here. And then everything else is inside the limit, so I'm going to use the limits there. See, I have a constant multiple, and then I'm using the sum and difference rule because I'm subtracting the two functions. So that will look like this. The limit as x approaches 2 of g is -6. My constant multiple, and then the limit as x approaches 2 of f of x is 4. Go ahead and work ahead of me on this so you can practice your math. Lots of negative signs. I got -21. Hopefully, oops. I got -21. Hopefully you did too. And that's it. So in the next video, I'm going to show you how to do more complicated equations. This video was just on our properties of limits and how to apply those.